All right, today we're going to dive into a really core concept in networking, one that's shaped so much of how our digital world works. We're talking about collision domains.
If you ever think back to the early days of the internet, or maybe those first office networks, remember how painfully slow and just unreliable they felt? Well, it turns out a huge reason for all that frustration comes down to the very thing we're talking about today. So, before we get all technical, let's just picture this. You're in a meeting room, no one's in charge, and everybody decides to talk at the exact same time. What happens? It's just noise, right? You can't understand a single word, messages get lost, and everyone has to stop, take a breath, and try again. That complete chaos is pretty much what a data collision looks like on a network.
Okay, so keeping that chaotic meeting in mind, let's put a more formal definition on what we actually mean by a collision when we're talking about networks.
So here it is. A collision domain is basically any part of a network where data packets can literally crash into each other. This happens when more than one device tries to send something out on that same wire at the exact same moment. And when they do collide, poof, the data's corrupted, it's useless, and both devices have to back off and try sending it all over again later.
And this is the most important rule to remember. Inside a collision domain, the network behaves just like that chaotic meeting. Only one single device gets to talk or transmit at a time. Every other device in that segment has to be quiet, listen, and just wait for the line to be clear. As you can imagine, this means the total speed of the network is shared, and every single collision just slows the whole thing down for everybody.
To really get this, we got to take a quick trip back in time. Let's look at the actual hardware that made these huge, clunky collision domains a reality in the first place.
So, who were the main offenders? Well, you're looking at the tech from the early days of Ethernet. We're talking about thick, shared coaxial cables. You might see them called 10-base-5 or thicknet, and these little boxes called hubs and repeaters. The one thing all of these had in common? They forced everyone onto one shared line.
A hub, for instance, was a pretty simple, you might even say dumb, device. It took whatever data came in on one port and just shouted it out to every other port, all at once. This meant that every single computer plugged into that hub was stuck in one giant collision domain, all fighting for their one turn to talk.
Now, to manage this mess, these old networks used a system called CSMA/CD. That stands for Carrier Sense Multiple Access with Collision Detection. And it was, well, inefficient. Here's how it worked. First, two devices try to send something at the same time. Bam! A collision happens and the data is toast. Then, both devices hear the electronic noise of that collision. And finally, each device has to wait a random tiny amount of time before it tries to send again, basically just hoping it gets lucky. You can see how this would grind a busy network to a halt.
But thankfully, technology doesn't stand still. And that brings us to the hero of our story, the network switch. This one device completely changed the game for wired networks and pretty much solved the collision problem.
Yeah, the switch was an absolute game changer. See, unlike a hub that just blindly blasts data everywhere, a switch is smart. It actually knows which device is plugged into which port.
And the difference is just night and day. With a hub, you have one big, slow collision domain for everyone. But with a switch, it creates a tiny, private collision domain for each and every port. So instead of sharing bandwidth, every single device gets its own dedicated lane. The jump in efficiency was just massive.
And here's where it gets even cooler. Modern switches allow for something called full-duplex communication. That's a fancy way of saying a device can send and receive data at the exact same time over the same cable, which means the possibility of a collision on that link just disappears. That one-at-a-time rule, gone.
So, problem solved, right? We can all go home. Well, for our wired networks, for the most part, yeah. But the idea of a collision domain is actually more important than ever when we look at the technology we all rely on constantly, Wi-Fi. Think about it. Wireless signals travel through the air, and you can't give every device its own private airspace. So Wi-Fi is inherently a shared medium. That means every single thing connected to your router, your phone, your laptop, your smart speaker, your fridge, they're all sharing the same radio frequencies. They're all in one big collision domain.
And because of that, wireless networks had to get smarter. Instead of just detecting collisions after they happen like the old wired networks did, Wi-Fi uses CSMA/CA. That A stands for collision avoidance. The whole goal is to prevent collisions from even happening in the first place by having devices sort of listen for a clear channel and signal their intention to talk before they do.
Wireless also has this extra tricky situation called the hidden node problem. This is where, say, your laptop and your smart TV can't hear each other because they're on opposite sides of the house, but they can both hear the Wi-Fi router in the middle. So they might both try to talk to the router at the same time, and their signals collide right there at the access point, causing problems.
So, okay, let's wrap all this up. Why is it so important to understand this concept? Even today, what are the big takeaways?
If you're going to remember anything, remember this. 1. Collisions are what happens when multiple devices try to talk on a shared network at the same time. 2. Old tech like hubs created these huge, slow, and inefficient collision domains. 3. Switches were the heroes for wired networks, giving each port its own private domain. And finally, 4, the concept is still super relevant because Wi-Fi is basically one giant modern collision domain that tries to avoid collisions instead of just detecting them.
And that really leaves us with a pretty big question for the future. You know, we went from just a few computers on a single wire to a world with billions upon billions of wireless devices all screaming for airtime. As we connect everything from our cars to our coffee makers, you have to wonder, what new kinds of digital traffic jams are we creating? And what clever new switches are we going to have to invent to solve them?